Hello friends, welcome back to my channel. In this video, we shall learn about magnetism, the concept from physics related to Gpstr exam 2022 syllabus. Before that, all those who have subscribed to my channel, thank you so much. And those who are watching this channel for the first time, watching this video for the first time, please do subscribe. Press the bell icon so that you will get all the notifications of the video which we upload here. Okay, so in previous class we have learnt about fundamental units in physics. So the video description box, please check it out. Video's link is given in the description box, and also about mathematics classes you can check it out in the playlist box. Okay, so come, let's move into the topic. So this magnetism is an easiest chapter. You can score here. The word magnet comes from the word magnesia. Okay, so let's see what it is. The first known magnet was called as lodestone. That's nothing but an ore of iron oxide, Fe3O4, iron oxide. So this was mainly found in a place called Magnesia, in which present Greece. This Magnesia is in Europe, southern part of Europe. In Greece it is situated, and some part of Asia also this lodestone was found. That was minor in Asia. Okay, so and the Chinese were the first ones to use these magnets as their guide to the boats. It was around 2500 BC, and we can divide this magnet into two types: natural magnets and artificial magnets. Natural magnet is nothing but the lodestone, and artificial magnets, basically they are classified or named like this as bar magnet, horseshoe magnet, magnetic needle and magnetic compass. These are the type of artificial magnet, and this magnet word comes from the word magnesia. Okay, remember this. And any freely suspended magnet comes to rest in north-south direction. Why it is so? When we consider this earth as a giant magnet, we know the geographical directions, that is geographical north, south, east, west directions. Magnetic south pole is in north direction. Magnetic north pole is in south direction. Okay, I repeat this. We know that according to the geographical directions of the earth, north, south, east, west, these are the four main directions. For magnetic south pole, is it in geographic north? Magnetic north pole, is it in geographic south? Okay, hence freely suspended magnet comes to rest in north-south direction, because south will be attracted to north pole, north pole will be attracted to south pole. That is one among the properties of magnet. Okay, let's see about that. Before that, let's learn about magnetic field. What are magnetic field? You look at this diagram. In this we have two poles, north and south pole, and these dotted lines are magnetic field lines. How they are situated, you see, they seems like they enter through this north pole and they move out towards the south, and the space around the magnet in which the needle of a compass rests in a direction other than geographic north and south direction is called magnetic field. Geographic north and south direction is, this will be our magnetic north and magnetic south. Hence geographical south is here, geographical north is here. Other than this two direction, you will find this field. So this is magnetic field. Okay, the compass rests in this north south pole. If this is a compass, this will rest in north south direction. Other than this, you see this field, the space around this is called as magnetic field. And magnetic field is a vector quantity. What is vector quantity? Any quantity which has both magnitude and direction is called vector quantity, whereas scalar, we say that the quantities which possess only magnitude. Okay, if it is having direction also along with that, that is called as vector quantity. Hence magnetic field is a vector quantity. And moving to properties of magnet, this is important. So let's see one by one. Mainly three properties. Those are attractive property. What do you mean by that? Attractive property of a magnet is the property in which the magnet attracts the magnetic material towards it. Okay, magnet gets attracted towards the magnetic material, or magnet attracts the magnetic materials towards itself. That is what is attractive material, attractive property. We can meanwhile we'll see about this magnetic material also. What are magnetic materials? The materials which are getting attracted by magnet are called magnetic material. For example, iron. Iron will be attracted by magnet. So iron is a magnetic material. Nickel. Nickel will be attracted by magnet. So nickel is a magnetic material. Hence, the attractive property of a magnet says that magnet attracts the magnetic material towards it. Then directive property. Directive property says that any freely suspended magnet comes to rest in north-south direction. Okay, plainly when we say about north-south, we refer to geographical north and south, you must remember that. Okay, so freely suspended magnet comes to rest in north-south direction. That is what is directive property. About poles, when we speak about, magnet consists of two poles, north and south poles. Okay, suppose you consider a magnetic material, magnet, and you break this as two poles and you break this into two halves. Again, this half and half magnets will have north, south. This will be north as usual and this is south. Again, this is south already, so this will be north pole. Again, you break this into two halves. Again, this piece of magnet will have north and south pole. This piece will have north and south. Again, if you break, so poles always exist in dipole. Okay, means not monopole, not a single pole. It always exists as a pair of poles, north and south pole. And also like poles means same poles, north, north. If you bring two magnets closer, north pole and north pole of two magnets closer, they will repel. Repel means they will not get attracted. Same way, when you bring south and south pole together, it will not get attracted, it will repel each other. So how do you say that? Like poles of magnet repel each other. Like poles. Unlike poles of two magnets attract each other. Unlike poles means one north pole and one south pole. Okay, or south pole and north pole. Like poles of magnet repel each other. Unlike poles of magnet attract each other. Cleared? Okay, now we shall learn about magnetic lines of force. The imaginary lines that we have mapped out around the magnet is called magnetic lines of forces. You see, when you take this magnet and we know we have learned about magnetic field around the magnet. So if you draw an imaginary lines around this magnet using the compass, and it is given in the experiment part in the textbooks, you can refer the textbooks for this experiments, and that experiment will not be asked in the exams, I hope so. So but the properties will be asked, so better revise these properties mainly. And if you want to go more in detail, please check out the experiment which is given related to that, how to draw the magnetic lines of forces. Okay, now so these lines have some particular property. They are closed curves. You see, they are closed curves, and they are continuous curves also, not like one curve there is a curve and again there is a break again. No, they are continuous curve and they are closed curves, and they are directed from north to south. As you see, look at this arrow marks, they indicate that they are directed from north to south pole. Remember this. They never intersect each other. You will not see them one line like this, magnetic field lines, another line crisscross like crossing this, intersect like this. No, they are beautifully formed like this without intersecting each other. Then they are crowded near the poles. Here you can see many magnetic field lines. Why it is so? Means the strength of the magnet near the poles are greater. Okay, near the poles the strength of the magnet is greater. And if these magnetic field lines are placed properly, like if they exhibit this property of equal distance or parallel distance also, we can call them. Parallel means two equal lines with the same spacing. So suppose if these field lines are like this, equally distributed, then we call them as uniform magnetic field lines. Okay. Next, we shall move into the next concept, that is solenoid. What is a solenoid? If a conducting wire is wound in form of a cylindrical coil whose diameter is less in comparison to its length, then the coil is called a solenoid. You can consider a cylindrical coil, okay, and then you have to wind a wire around this, so and connect this to the battery, positive and negative side of the battery, and that forms a solenoid. Here we have not shown. You can just imagine that they are connected to the battery. When you connect them like this, through this connecting wire current flows, and this system acts as a solenoid. So for the cylindrical coil, you can consider any cardboard, cylindrical cardboard, or it could be of plastic pipe or anything like that. But this material which you wind around the cardboard should be a conducting wire, and the diameter should be less in comparison with the length. You see, look at this, the diameter is very less comparing, we can make out from the figure, the length is more. And you should not take like this coil where the diameter is more and the length of the coil is less. Like this, if you consider, it doesn't form the solenoid. Okay, so let's see about the properties of the solenoid. You see, like this only, in a solenoid the magnetic field lines takes its position or place. These magnetic field lines are straight lines inside the solenoid, and they are parallel to the axis of the solenoid. So if you take this is the axis of the solenoid, and here inside they are parallel to this axis. Then these are very important points. Few exams it is repeatedly asked. Please concentrate. These magnetic field lines are denser when we increase the current in the solenoid. Okay, so they can ask you how the density of the magnetic field lines could be increased in a solenoid. By increasing the current. Suppose you are connecting this to the battery actually. So you increase from 1 ampere to 2 ampere current. So here you can find the strength of this magnetic field lines will be more. Then magnetic field lines will also be increased by increasing the number of turns of the coil. This arrow mark indicates increasing. Increases. When you increase the number of turns of the coil, instead of 4 turns, you can take 5 turns, 10 turns of the coil. You can increase the magnetic fields around the solenoid. And also by keeping a soft iron rod inside the solenoid, you can increase the magnetic field strength. You place a soft iron inside the solenoid, it will increase the magnetic field strength. Okay, so these are the main points from solenoid. So you can also refer the related materials. Meanwhile, I think these points will be helpful for that. Okay, come, let's move into the next topic. As I have told you earlier, there are a lot of topics to be learned from magnetism chapter. We are covering only which is related to Gpstr exam 2022, which is given in the syllabus. Okay, so that at least we can guide few. So for more reference, please check out with the textbooks from 6th standard to 12th standard textbooks, NCERT textbooks preferably. If you get ICSE or CBSE textbooks also will be fine. Okay. Next concept is force on a current carrying conductor in magnetic field. This is nice topic actually. So we'll cover up the important points. You take a conductor, a charging conductor, a charge moving in a magnetic field in the direction other than the direction of magnetic field experiences a force. I repeat, a charge moving in a magnetic field in a direction other than the magnetic field experiences a force. So imagine here, this is the magnetic field. You consider 3 axes, x axis, y axis and z axis. Among this x, y and z, along the x axis you consider current I, that is flow of charge. Here along the y axis you consider B. B stands for magnetic field. Other than this two direction there exists some force F. Okay, that experiences a force. That force is called as Lorentz force, and we can denote this like this, where that force is directly proportional to I. What do you mean by this directly proportional? We always refer this directly proportional, this symbol. It means when we compare two quantities, when one quantity increases, this left hand side quantity if you consider, when this increases, this also increases. When this quantity decreases, simultaneously this also decreases. That is what mean by directly proportional. If it is inversely proportional, when we say inversely proportional, suppose if it is x is inversely proportional to 1 y, let us take, that means 1 by y we write. And how do you read this? X is inversely proportional to y. Okay, what do you mean by this? When x increases, y will decrease. When this quantity increases, this decreases. When this decreases, the other quantity increases. Okay, they are opposite in nature. That's why we call this is inversely proportional. Okay, here first point is this force, the Lorentz force is directly proportional to I, current. Then force is also directly proportional to B, magnetic field. Then force is also directly proportional to length, L, length of the conductor. Then when we combine all these three, this F is common, so we write F proportional to I into B into L. Okay, F proportional to IBL. Whenever we remove this proportionality constant, proportionality sign, we have to put a constant sign. Suppose we take x proportional to y. Let us take, I want to remove this proportionality constant, so I have to put a constant term is equal to k into y, where this k is constant. Same way, whenever I remove this, I just insert a constant k. Therefore, this equation become, suppose if that k is equal to 1, if you consider F is equal to I into B into L. So, this is the expression for force on a current carrying conductor in the magnetic field. And you rearrange this equation and make B as subject of the formula, keep B this side only, take I and L to the other side. So, multiplication, this will go to division now, I divided by L. So, you will get B is equal to F divided by I into L. Hence, we get this equation for magnetic field. This is the expression for magnetic field for a force on a current carrying conductor. Okay. And let's see about the unit. This is also very important. Please focus on. What is the SI unit of force? SI unit of force is Newton. For current, ampere. For length, meter. So, this could be written as Newton per ampere per meter. When you take these two quantities to the numerator, it becomes to the power of minus 1. To the power of minus 1. Okay. Or this is also called as Tesla. Symbol is T. The unit of magnetic field is Tesla. We can also call it as Tesla. Or this can also be called as Weber per meter square. Weber per meter square. Cleared? So, we have almost covered up the second chapter, which is given in the Gpstr syllabus from physics concept. If you would like to share any issues, please comment in the comment box. In the next class, we'll see about a few classes of mathematics also. So please subscribe our channel and don't forget to press the bell icon so that you will get the notifications of all the videos which we upload here. Thank you so much.